All right, that was the Streets of Laredo, an American folk song. So there we go. All right, here we are. Back to Friday morning. Woohoo! Okay, and not that we're all sad to see the weekend come, but here we are. Okay, so first of all, let's go over study guide. Hopefully you've already done it and got credit for that. I will be checking that here shortly. But anyhow, let's go over this part. First of all, axial versus appendicular skeleton. Okay, I'm going to make that red as my axial. The axial is going to be the axis or the main middle axis of the body. It's going to be the skull. It's going to be all the ribs and the vertebrae all the way down through the sacrum. Okay, but the appendicular, all right, oh, let's make it blue. That's a nice blue color. All right, red and blue, and then white on your paper. So very patriotic. We're red, white, and blue today. All right. So the clavicle up there, the scapula, which is part of the pectoral girdle, and then of course all the arm bones would be that. And the same thing over here, the shoulder blade, the clavicle, and all the arm would be that. And then same thing, the legs are also appendages, so that makes them appendicular. All right, as is the other leg. All right, and the pectoral girdle that attaches the appendages would be part of that. So the hip bones here and the hip bones there are all blue. So basically, axial is the main axis or middle part of the body. The appendages, arms and legs, along with the bones that help attach them, the girdles, are going to be appendicular skeleton. All right. Now, hopefully you didn't just list the 5 functions. I'm just going to discuss them. You can write down what you haven't got. Basically, we said, first of all, they support. Okay, they give support to the body. It helps hold the body upright so the body doesn't just collapse into a little blob of jellies rolling around the floor. Okay, protection particularly protects the soft organs of your body, particularly your brain, your spine, your heart and lung are protected by your rib cage, and especially by your skull and your vertebrae, all protect your brain and spinal cord. So those are very important parts or protection that it does for us. And it just protects our body in general. Number 3, movement. All right. Now, movement, we tend to think of that as being something your muscles do, but your muscles have to have something to pull on to move things. If I didn't have bones to pull on, I would just have a bunch of quivering muscles that contract back and forth but don't do anything. Okay? And so there is no movement unless you have, of course, muscles to attach to. Number 4 is storage. To store things, particularly minerals like calcium and some magnesium and some other ones, and fat. In the inside of the bone, in the medullary cavity, we talked about how the yellow marrow or fat is there. Okay, bone cell formation, or hematopoiesis is a very important one. You need to know that word. Hematopoiesis, let me spell it real quick. Hematopoiesis. All right, P-O-I is po, and then esis. Hematopoiesis, which just means forming red and white blood cells. Okay, both red blood cells and the white blood cells. All right, it's in the red bone marrow, so you tend to think, oh, well, the red marrow or myeloid tissue, so it's going to make red blood cells, but it also makes all the white blood cells. All the blood cells come from the red bone marrow. It just makes a lot more red ones, and that's why blood is red. All right, 4 types of bones. All right, so first of all, we have long bones. Things like your humerus, your femur, your tibia, your fibula, radius, and ulna would be the main ones. Okay, we might also throw in your metacarpals and metatarsals. Phalanges, they're kind of it could be short bones, or they could be considered long bones too. Okay, but they have that shape where they're skinny in the middle of a knob on each end, and so we can put the metacarpals, and metatarsals in there. All right, short bones. Short bones are going to be ones that are just about blocky looking ones, particularly in your wrist, would be your carpals, your ankles, which would be your tarsals. Also your patella would fit in that category. Okay, so all of those we're going to call short bones. Now, flat bones are your skull case, especially most your skull bones, your ribs, your sternum, would all be considered flat bones. Okay. And then the last one is kind of, well, just weird shape. We're just trying to say, well, we don't know what to call them because they're not any of those other shapes. This would be like your vertebrae, which are kind of odd shaped. Your hip bones, the pelvic is considered irregular, although they're almost like flat bones, so that's kind of iffy, but we're going to call them irregular. Your mandible would be that. Some of your face bones, not really the skull case, but your maxilla and your nasal bone and some of those might be considered irregular as well. Some of them, like your nasal, are still pretty flat. Others, like your zygomatic, that's here in the corner, your maxilla, ethmoid, they're just kind of weird shaped bones, so they're going to be irregular shaped bones, okay? So your skull case is flat, but your face bones all up here, your jaws and face, are all going to be really considered irregular bones, okay? All right, now what it means we go down here and get some examples. Your calcaneus is a tarsal, even though it's pretty big, it's going to be considered a short bone. All right, your frontal bone up here, we said, is going to be flat. All right, your femur, main bone in your leg, so it's going to be a long bone. Your humerus, also the biggest bone in your arm up here, so it's going to be a long bone. Your sternum right here in the middle is very flat, so it's going to be a flat bone. Your mandible, we said, is irregular. Your metacarpals are long enough, we're going to call them long bones because they have that same kind of shape to them. And the radius on the thumb side, on the thumb side of your hand, is going to be a long bone, obviously, very long. And vertebrae is going to be irregular. All right. Going on this one, site of spongy bone in the adult would be at the epiphysis, each side, okay? Now, in children, you may have more spongy bone in other places, but by the time you're an adult, it's only at the ends where the bone marrow is. All right, number 2, site of compact bone in the adult would be the diaphysis, or the shaft there. Okay, so the diaphysis shaft is going to be where you have the compact bone. Number 3, site of hematopoiesis, or red bone cell formation in the adult, would be in the red bone marrow. All right, which would be the red marrow, which is D. All right, scientific name for the bone shaft is the diaphysis, the long skinny part. Shaft is hard, compact bone. Number 5, site of fat storage is going to be in the hole in the middle, which is the medullary cavity. And number 6, longitudinal growth, how they get longer, would be at the epiphyseal plate. If we want to know how they got wider, we'd say on the outside of the diaphysis. It just adds on bones to make it wider. But the epiphyseal plate's at the top and bottom that allows it to go up. All right. Now, in this paragraph, we're going to talk about some things here. We said your blood has to have a certain level of calcium because it needs it for your muscles to work, for your nerves to work. If it's short on calcium, it'll start taking calcium out of your bones, which can be bad for your bones, obviously, if it takes out too much, okay? So there are 2 hormones that control that. One is calcitonin and one is PTH, okay? If you don't have enough calcium and they're going to start taking it out of your blood, that would be PTH, parathyroid hormone. Parathyroid, thyroid is in your neck. Here, the parathyroid is near that. Okay, let's see, I think means behind, if I remember right. But the parathyroid hormone is PTH, and it says, hey, we need to let some out of your bones and get back into the bloodstream. Okay, and they release bone cells they trigger bone cells called osteoclast. Okay, notice clast. Anytime you see clast, these are going to be usually things that destroy things. Blasts make new bone. Osteocytes are just the mature cells. And then osteoclasts are ones that take away calcium or dissolve the calcium and release calcium back into the blood. Okay, so those bone cells are called osteoclast. All right, this calcium is essential for your nerve cells of this here, but also muscles. That's not on there, but that would work. When blood calcium levels get too high, though, you have too much, then calcitonin is released. So that would be calcitonin is released, which causes calcium to be put back into the bones as calcium salts. In other words, it starts adding calcium back to the bone. Think of it this way. Calcitonin tones up your bone or adds calcium to your bone, so it makes them bigger and stronger and everything else like that. So if you're going to get toned up, then you use calcitonin, whereas PTH takes it away from your bones. All right. All right. If you don't use muscles or lack of exercise, it will cause your muscles to get smaller, but it'll also make your bones get weaker. Your bones pull on the muscle. When they pull on the muscle, your body responds to that pulling by saying, oh, I better strengthen this up. So it puts more calcium there. So exercise not only makes your muscles stronger, it also makes your bones get stronger. So if you don't exercise, instead they atrophy, A-T-R-O-P. It looks like atrophy, but it's atrophy. All right, and so it's very important that you exercise even as you get older. Why? Because not only do your muscles atrophy, but so do your bones. All right, then it says large tubercles or extra deposits are going to be sites where there are stress or tension. That's what we said. It's going to add more bone material where there's stress or tension. All right, immature or matrix depositing bone cells. These are the immature bone cells, are the ones that are going to put calcium back on your bones, are the osteoblast. All right, once they're surrounded by the matrix, these cells become mature bone cells or osteocytes because they've been kind of walled in, trapped in. Now they have to mature and grow up. Okay. And it says our astronauts must do isometric exercise in space because bones atrophy under conditions of weightlessness or lack of gravity. So they found since they weren't having to lift and pull their bodies against gravity like they do on Earth, they actually would get less. So isometric is where iso means same. So it's when you push against yourself like this, you still get exercise even though nothing's going anywhere. And so they had to do exercise like that. I think now they even have like little exercise bikes or something up on the like the space station and stuff like that. Okay. All right. Number 7, causes and symptoms of rickets. Basically, it's caused by lack of calcium or if you don't have enough vitamin D. Okay. Vitamin D is something your skin makes when you're exposed to sunlight. It also is put in a lot of foods, sometimes breads, but definitely milk is usually says vitamin D. Sometimes, since some people don't drink milk or lactose intolerant can't drink milk, sometimes they put it in orange juice, since that's something people might have every day instead of milk and stuff like that. Okay, so if you don't have enough calcium, or you can have all the calcium you want, but if you don't have enough of the vitamin D to help your body use it, then you'll have problems. Rickets, generally the legs get bowed. They kind of bow out because they're not as strong as they should be, so you get kind of bow-legged on your weight-bearing bones that have to carry a lot of weight. And like I said, the way to prevent it is milk, bread, and other foods are fortified with vitamin D and calcium to try to make sure that we get enough in our diet. Okay, also getting outside to get enough sunlight to get vitamin D. Kind of one of those deals. Too much sunlight could cause cancer, but not enough sunlight, you don't get vitamin D. So you kind of need to do both. Okay, all right. Reduction sounds like you're getting rid of something. Okay, but reduction just means if you have broken bones, putting them back together so they line back up. And so that is a reduction. Now, a open reduction, second part there, is when they have to go in surgery, they have to go in, open the skin, and put it back in. Usually have to put bolts or pins or plates or something in there to hold the bones together. That would be open. Closed, for example, when I was in high school, I broke the 2 arms right here in a football practice. And so, but they could jiggle them around and put them back together without having to cut it open and do any kind of pins or anything. So that would be a closed reduction. Okay, so you have open and closed. It's that simple, just open and shut, if you will. All right, so let's go down here. If a bone is broken cleanly, the ends do not penetrate the skin, then that is a simple fracture. Okay, so like mine, they broke, but they didn't stick out or anything like that. So that's considered a simple fracture. Okay, more simple for them than for the person getting the fracture, I'm sure. But anyhow, non-surgical realignment would be a closed reduction, or A. Number 3, a break common in children. Okay, where the bone splinters but not complete. Okay, when a kid's bones are still kind of rubbery, they're not 100% hard calcium like ours yet, and so a lot of times they will bend and it'll kind of splinter off, but it won't completely break, and that's called a green stick fracture, kind of like a branch. If you have a dead branch, it just snaps. That's just adults. Okay, once we're adults, then it is snap. But if they're young, they still have flexibility and they kind of bend a little bit, and yeah, parts of it kind of break off, but a lot like a green twig would do on a tree. So it's called a green stick fracture. Okay. All right, we're going to stop right there, and we're going to come back in another video, just a second, and we will finish up the last little bit here, and we will be done.